from April 2019. And 30 says, according to figure 1, the percent reflectance of the flower petal of the Monotropsis odorata plant from light at the wavelength of 600 nanometers was approximately something. So first thing I do when I'm looking at a figure question is I just want to go back to the figure and sort of make sense of what's going on. So what's being measured within it, what are some of the general trends, and that will help me to make sense of what the question is asking. So here's figure 1. And so basically we have reflectant patterns of leaf litter and Monotropsis odorata structures. So basically we have 4 things that are being measured. We have the leaf litter, which is sort of like the surrounding stuff on the ground around this plant. We have the bract, which are these leaves that evolved as camouflage. We have the flower petals, which are the flowers, and the reproductive stem, which is the stem of the plant. Here on the y-axis, we have the percent reflectance from 0 to 45%. And then here we have the wavelength in nanometers. So basically, as they're increasing the wavelength, right, of the light that they're shining on it, basically what's the percent reflectance that we see. And then they're measuring the trends. 2 major trends we should notice is that the leaf litter and the bract sort of go together. Boom, boom, boom. And then down here, the flower petal and the reproductive stem sort of go down here. And this makes sense if you remember this from the passage, because the whole idea is that the bract are sort of the mechanism for camouflage. Those are the outside leaves that are covering the plant. And what they're designed to do is to match the leaf litter, which is sort of the surrounding environment. So it would make sense that their reflectance, right, or the way that they reflect light would be similar so that they can kind of blend in together. In contrast, the flower petal and the reproductive stem, we're told are this bright purple color, right? So they sort of go together and they're not going to match the surrounding environment. That's why we need the camouflage. So let's go down one more time. And here we have this. They're basically looking for the percent reflectance of the flower petal, okay, flower petal, percent reflectance for light at a wavelength of 600 nanometers was approximately something. So this is basically saying when we're shining the light of 600 nanometers on the flower petal of this species, what is the percent reflectance? Okay, pretty easy. So let's go back up. We're going to look for the flower petal, which is this bigger dotted darker line. That's this right here. Basically, when we're shining a wavelength of 600 nanometers, which is going to be about right here, what is the percent reflectance? We carry it down, and it looks to be exactly at 5%. So for that reason, we'll go down here, we'll choose 5%, and there we go, 5%, and that is our correct answer for question number 30.